Hi, I'm Martin, and welcome to Groundhog Graphics. This is Chapter 2, Programming in C. In this chapter, we are going to receive input from the keyboard using the getc function and scanf function. We will be using the data types char, int, and float, and sending output to the screen using putString function and printf function. Alright, let's go ahead and create a project. And from the projects menu, we will select console application. And this will be a C file, so select C. Next. This is chapter 2, CH2, example 1. Click next. Yes. GNU GCC compiler. Yep, everything's good. Defaults are fine. Finish. Yes. Yes. Yeah, I'm overwriting the lesson I went over earlier, so you won't have to do that. Alright, so now we go to sources. We go to main, double click main to open it. And there is code blocks. Put their program in for us. We're going to delete that. Select it. Delete. Now I'm going to go ahead and include stdio.h. And I'm going to put our main function in. Int returns. Main returns int. Main void. And there we go. So now I'm going to start off by defining another character variable. And we'll put char c equals apostrophe capital A semicolon. And now here's another one. Now here's the an int. Now we've seen int before at the return for the return type for main, but we've never used an int. So int I, and we'll go equals to 65535. Okay. So what is an integer? An integer is a whole number that does not have a decimal point. There's no fraction. It's not a fraction. The integer is good for addition, subtraction, multiplication, but not division. Because division, usually you're going to end up with a remainder, and int can't handle any kind of remainder. So now I'm going to go under here, and I'm going to put in a float value. Float f equals 1.2 e1. Now what a float is a float is for fractions. It lets us do our division problem and put our quotient in the variable f, and it'll handle it. Now it also can represent very large numbers because it also supports exponents. So that's why you see I put the e1 there. So the only letter you can put in a number is for a float, and it is e for exponent. So 1.2 exponent 1. Now there is something else I should add about float. Float has an issue. When we put in a decimal number, oftentimes when we see the output, the number will be slightly different than the number we entered. And that's because we have to convert from decimal to binary. Binary cannot represent all decimal numbers exactly. So what that means is float values or float variables can represent decimal approximations only for fractional numbers. Any integer value can be represented exactly, and there's no problem. It's only anything to the right of the decimal place. So now let's go down and let's put a printf function, and let's open quotation, and let's see, let's put c equals %c for character, and we will put it as escape sequence. \n is an escape sequence of n. N means new line character. put a comma, and we'll put our variable c there. Now we go underneath, do this again. This time for I equals %d. Now this format specifier, %d, we haven't used yet, and what that means is decimal number. So that %d is what we use to represent an integer. So I know it'd probably be more sense if it was %i, but it's not, it's %d. So then we will still go with our \n, and then we will put comma and our integer I. Close parenthesis. Now, for our float, printf, quotations, f equals %f for float, and \n, comma, f, and semicolon. And for those of you that need to pause output, we'll go ahead and put in a getc, stdin, just in case when you run your program and the window that shows you the execution goes away rapidly, then this will stop that. Alright, so now we go ahead and F9 to compile and run it. And there we have C equals the letter A, I equals the 65535, and E equals 12. Because we put in, I believe, it was 1.2 with the exponent of 1. So it shifted it to the left by 1 place. So that's right, there it is. Now, so what's the difference between a char, an int, and a float? Well, there's two differences, okay? For one, each of these data types represents or potentially represents a different number of bytes in memory. Like this character right here, char, is 1 byte. In every compiler, it's going to be 1 byte. But int, depending on the system, the hardware that you're running, the compiler version, can vary in different sizes. It can be as little as 2 bytes. In this case, it's 4 bytes. Some cases it can be, I think, 8 bytes. So let's actually get some input from getc. Let's get some input from the keyboard. Keyboard input always comes in as a character, so we use our data type character, which is C up above. So we're going to go C equals getc stdin, standard input. Now, what will happen is when we type something on the keyboard, getc will pull that value from the keyboard queue, and it will assign it to our variable c, and then underneath it we have our printf function, which will then print out the character we just typed. So let's go ahead and execute with F9, and now you see there's nothing there. Let's go ahead and hit the letter K, press enter, and now you see C equals K. So that's how we can get a character from the keyboard. Okay, now let's make this a little cleaner. Let's go ahead and let's write out some text, so at least when we come up with a screen, we don't have just a blank screen. We don't know what does the computer want. So we'll put in put S, stands for put string, and put string is a nice alternative to printf. If you don't need any format specifiers, if you're not using any variables, you're just printing some text on the screen, put string is what you want to use. So let's see, please enter a character, period, and we end it with a semicolon. And what that'll do is it just prints the string, and it will also print the new line character for us. So we don't have to, you can't even use escape sequences like the new line character in here. This is strictly just for put string, put the text, a string of characters on the screen. Now let's go ahead and execute with F9. Please enter a character. Okay, let's put Z. C equals Z. So now we know how to get input of at least one character from the screen. So now let's say we wanted to get input for a number. So let's put string, whatever you want to call it. Please enter a decimal number. Semicolon. And now we're going to use a function called Scanf, which stands for scanned format. Scanf. Open. Now Scanf is very similar to printf. It has formats, kind of specifiers and things in it. So we go at open quotation mark with Scanf, and we're going to tell it we're looking for a decimal number. So we'll put %d, and then we'll put a comma, and we'll put our variable I there. Oh, yeah. We actually have to use an ampersand symbol right here. Ampersand I. And the reason why that is this is for something in C we call pointers. We're not going to get into pointers in this video. It's more of an advanced topic. So for now, make sure to put in the ampersand symbol, the and symbol, and then put in the I. And what it'll do is it will assign whatever we type to the keyboard, will assign that to the direct memory location where I is. For now, it just stores it. Let's just say it stores it in I. Put a semicolon. Now we're still going to end up having a problem with this function, and I'm going to explain it. But let's go ahead and execute it so we can see the problem. So F9. Please enter a character. Sure. Letter E. Please enter a decimal number. Oh, we didn't have the problem this time. Okay, that's fine. But we can have this problem, and I will show it to you. Enter a decimal number, 256. And now we see that C equals the letter E, and I equals 256. Scanf can be used to input strings. It can be used to input floating point numbers. Let's do a floating point number. Puts, please enter a floating point number. And we'll do scanf, open parentheses, open quotation, %f for float. And we'll put comma f for our float variable. Oh, now I forgot the ampersand symbol, which is a shift 7. And let's go ahead and run it. Okay, please enter a character. T. Please enter a decimal number. 300. Please enter a floating point number. We can actually put the letter E in this floating point number. It's acceptable for floating point to have the letter E, so we can do 0.12 E2 for exponent. Let's see what we get. So there we go. C equals T, I equals 300, and F equals 12. So there it is. So now we know how to get input for an individual character, for a decimal number and for a floating point number. So now the problem I'm talking about is when we do get C up here, and we enter a letter like the letter T we just did, or E, we hit enter. When we hit enter, the enter key goes into the keyboard queue. Get C pulls out the letter, but it doesn't pull out the enter key. So the enter key sits there. So sometimes, like I say, if I had another get C right after this, let's actually make another variable. Let's call it character extra input. Character extra input, semicolon. Now let me go under here and go extra input equals get C, stdin, semicolon. Now under here, let's go ahead and put under our character printf, open parenthesis, open quotations, extra input equals, and this time I'm going to do a %d because I want to see the decimal number, not the actual character. that extra input is going to represent. So by using the %d and putting a comma here, and then placing extra input variable there, we can now see the numerical value, which is something I guess I should have mentioned earlier too, when I mentioned that the character data type can represent a range of 0 to 255. Well, all the letters are actually a part of the ASCII table, which stands for American Standard Code for Information Interchange. And that table means every letter, it shows that every letter has a number associated with it. So that's why I said character can represent 0 to 255, because each character does have a number represented, a number associated with it. So we have extra input equals %d extra input. Now this will give me a warning, and that's fine. I'll cure the warning for you, but how I do it, we're not really ready to get into yet. But I'll go ahead and show it quickly. But here, let's go ahead and run it. F9. Please enter a character. Okay, the letter Q. Please see now, it didn't ask for another input, or maybe it didn't even pause for another input, which seems odd, right? Right. So that's because the other getc, the second getc, pulled the enter key from the keyboard cue and then continued on. So now we enter a decimal number, which 100. Enter a floating point number, let's say 23.4, and we'll just do that, and we'll see what we get. Now I'm going to tell you the ASCII code for enter. If you look up in the ASCII table, will be LF for line feed, and that will be number 10. And let's see what we have. So we have C equals Q, extra point. Oh, didn't do a backslash in. My bad. So extra input equals 10, and then I equals 100, and F equals 23.4. So that's all right. So extra input equals 10, which is our enter key, just to show you. So that can confuse people. Let me put backslash in here, and let's rerun it. Now you can see, oh, no. Okay. Q, and number 200, and floating point 23.4. There you go. Now you can see it a little clearer. So extra input equals 10, I equals 200, and so forth. So, like I was saying, that's that enter key being stuck in the keyboard cue can actually cause some confusion when you're writing a little C program like this, because you put the getc in, you're like, oh, I want to get the character, you hit enter, and then your next getc for some other input that you wanted, well, all of a sudden it doesn't work. You're like, why is that not working? Well, that's because the enter key is also stored in the keyboard cue. Alright, so now remember I said we were going to have a warning, so let's go down here and see if we have the warning. 0 errors and 0 warnings. Oh, okay, well, we don't have it. So, %d, extra input is a character. Okay, well, we don't have the warning. I thought it would warn us, because doing printf with extra input equals %d, that's for decimal for an integer type. So printf would be expecting an integer type. However, extra input is a type character. So it could potentially give us a warning because we're trying to kind of mix data types here. But in this case, it didn't care. It's fine. So it worked, and we'll just leave it at that for now. The fix for it would be for casting one type to another type, but we'll get into that in another tutorial. Right now we're just learning some basic stuff. Alright, well, this concludes Chapter 2's video. Thank you for watching, and I will see you in Chapter 3. Bye.